Schrödinger's cat. Most of you probably know what that is, but in this video, I will explain to you what this quantum mechanical thought experiment is really all about.
And of course, whether the cat is still alive or if it is dead, feel free to subscribe to my channel, leave a like, write a comment, and let's get started.
Erwin Schrödinger was an Austrian scientist who was born in 1887 and who, you could say, achieved his greatest feat by making cat content famous.
Before there was even the internet, which daily provides us with cute cat pictures. Apart from that, he was also one of the founders of what is known as quantum mechanics.
Quantum mechanics is the physical theory that describes the properties and laws of states and processes of matter, and in contrast to the theories of classical physics, describes the accurate calculation of physical properties of matter in the largest range of atoms and below.
And Schrödinger also received the Nobel Prize in Physics in 1933. So for quantum mechanics, not for the cat content. Schrödinger has become famous and is still known today as a kind of internet phenomenon because of the thought experiment of Schrödinger's cat. I'm sure all of you have seen some meme about Schrödinger's cat, but I have the feeling that most people don't really know what Schrödinger was trying to say with this thought experiment. Change. First of all, it's very important to note that Schrödinger didn't actually put a cat in a box. That was just a thought experiment, so no cat was harmed. Let's take a look at what this thought experiment looks like. This was just a thought experiment, so no cat was harmed. Let's take a look at what this thought experiment looks like.
So here's how it goes. You put a cat in a box. Schrödinger describes this box as an infernal machine. In addition, a radioactive apparatus, a Geiger counter, an instrument for measuring radiation, a hammer, and a bottle of deadly prussic acid are placed in this box. Over the course of an hour, one of the radioactive atoms from the apparatus may decay, but it doesn't have to. If it does, the Geiger counter goes off, which in turn sets a hammer in motion. The hammer smashes the bottle of prussic acid and the poor cat would be dead. The apparatus would kill the cat within an hour, so with a probability of 50%.
The cat is 50% dead, 50% alive. Schrödinger now poses the question about the quantum mechanical state of the cat. And that's really the essence that you all probably know from this experiment. They say that as long as you don't look inside the box and don't know, the cat is either dead or it is alive. Now let's stop with the cute cat pictures. Now comes the important part about the thought experiment and the part that most people have never heard of. Schrödinger didn't intend to make a statement. He critiqued quantum mechanics in daily life. He aimed to make a critical point about the applicability of quantum mechanics to our everyday physics. In quantum mechanics, it is indeed the case that the state of an object depends on whether someone is looking. This means that an object can have multiple states at the same time when no one is looking. This is referred to as superposition. I know, it's all super difficult to understand. So here's a vivid example that is super exciting. The so-called quantum entanglement. Let's imagine an electron.
Electrons are negatively charged, tiny elementary particles, and have something called spin, which for the sake of simplicity we will imagine as rotating in one direction. Let's also imagine that one electron has a spin of 1, so it rotates in one direction. The other electron has a spin of -1, so it rotates in the opposite direction. These electrons can be entangled, quantum entangled, so that their spin always adds up to 0. If we reverse the spin of one electron, the other will automatically change direction as well, so that we end up with a total spin of 0 again. And now comes the crazy thing about quantum entanglement. The two electrons respond to each other instantly, no matter how far apart they are. If the electron on one side of the universe changes its spin, the other electron, even if it is millions of light years away, will also change its spin immediately, instantaneously.
Albert Einstein could hardly believe that this quantum entanglement exists because it seemingly violates the principles of the theory of relativity. Because if these two electrons react instantly over millions of light years apart, it seems like information is being exchanged faster than the speed of light. He therefore called this phenomenon spooky action at a distance. In the meantime, there are already some theories explaining why this is indeed compatible with the theory of relativity. You can think of the two electrons as an object, like two sides of a coin, but spatially separated from each other. You can already tell in quantum mechanics almost anything is possible. Quantum entanglement is an example of the superposition or state overlay mentioned earlier. Because it gets even crazier when no one is looking, when no one is examining the electrons, they are simultaneously entangled and not entangled. That means their state depends on whether we are looking. Totally crazy. Back to the poor cat in its box. The principle of superposition can also be applied to the radioactive particle. Here we can definitely identify a quantum mechanical effect. The particle is both decayed and not decayed until we take a look.
And since the life of the cat depends on whether the particle decays or not, Schrödinger says that the cat is both dead and not dead at the same time. The quantum mechanical superposition of the decaying radioactive particle could also be transferred to the cat. But Schrödinger actually wanted to express the opposite of this quintessence, namely that the cat is dead and alive with this thought experiment. He wanted to demonstrate that it makes no sense to transfer this quantum mechanical rule of superposition to objects in our everyday lives. In principle, he wanted to say a radioactive particle can be in superposition, but a cat cannot be in superposition. Each of us knows that a cat is either dead or alive. There's no cat that is dead and alive. So Schrödinger actually wanted to say with this thought experiment that quantum mechanical principles cannot be transferred to everyday physics.
So, the Schrödinger's cat thought experiment raises the question of where quantum mechanics stops and where everyday physics begins. Where exactly does the realm of superpositions and state overlaps begin? To this day, it's still not entirely clear where exactly the boundary lies. Geza Giedke from the Max Planck Institute for Quantum Optics said the following about it.
The quantum world is typically small, cold, and empty. Everyday life, on the other hand, is large, warm, and full. There is air or water around us and many systems that interact with each other. And quantum systems, in which you can see these phenomena in their purest form, are very well controlled and isolated, and that is not the case in everyday life. Oh man, it's all pretty complicated. To help you relax, here are a few videos of cats that are definitely alive for you.
The boundaries between quantum mechanics and Albert Einstein's general and special theories of relativity are incredibly fascinating. In my last video, I went into great detail about the speed of light and the question of whether something might be able to travel faster than light, and if not, why not? And what about quantum entanglement? Does it perhaps break the principle of relativity? If you're interested, then click on the video displayed, and if you have any questions about this complicated topic, feel free to write them in the comments and I'll respond to you. Otherwise, we'll see each other in the next video. Take care, everyone. 2001